Welcome students for the today's session on software design. This particular lecture is part of your course on the software engineering. Earlier we discussed about the software engineering models, software requirements analysis and many other topics. Today we will be discussing about the software design. Whenever you are writing a program, you will just write the program directly. That program may be of 20 lines or 30 lines or 50 lines, whatever it is. But when you are working on a real life project as part of your job or as a freelancer, then all the concepts related to software engineering come into picture. Developing a project successfully is not possible in case you are not well versed with the concepts of the software engineering. During our earlier discussions, we discussed about software engineering models, particularly software development lifecycle models such as waterfall model and other things. Then we discussed about how to take the requirements from the customer for which you have to develop the software, that is SRS, of course CRS, all these things. Today we will be discussing about the software design. This is first part of a series of presentations on software design, and first of all we will try to understand what is design. Now forget about programming, forget about developing the software. Suppose somebody wants to build a house. So you should be well aware that a plan or a map or a diagram of the house to be built is made on a chart which is two-dimensional and is showed to you by the architect, for which you need to take approval from the civic authorities. So when you look at the chart, you will be knowing how many rooms are there, where is kitchen, where is entry, where are windows, what is the area of the each room, many things. However, the limitation is that it is two-dimensional in nature. You will not really have a very close feeling of building such a house and really walking through it. Then we started having clay models. The clay model is brought to you and is explained to you that where is what. Then came the three-dimensional models with virtual reality, wherein you can walk through the house which you are going to build. Similarly, design plays a major role even when you are building software. Until now we spoke about building a house. Since you all aim to become software engineers, if not all, most of you, our objective is to build software successfully. Just like a house, in case you build software with some flaws, then that software may not be usable. In the case of a house, at least you can use it. But in the case of software, maybe it needs to be thrown out, and whatever effort has been put into it becomes futile. Hence, the design is very important. Now, in the case of software design, how the software is designed? This is the question for today's session. So, the objectives of today's lecture are understand software design, understand data design, and understand the architectural design. Basically, data design, architectural design, they are part of the software design. There are other design techniques also, which we will be discussing in future sessions. Today, we will confine to the meaning of the software design and also the data design and the architectural design to the extent possible. What I expect from you is that whenever you are attending this session, beforehand I want you to go through the course material of your software engineering course, particularly the unit 3 of MCS 213 on software design. MCS 213 is the course code of software engineering and unit 3 is the software design. Then you can easily understand and you can even interact through our toll-free numbers. So first of all, let us focus on what is software design. It is the process of defining the architecture, components, modules, interfaces and data for a software system to satisfy the specified requirements. You may not be aware of all these things in case you are just writing programs. in case you are not doing mini projects, in case you are not writing large programs, then you may think that all these things are unnecessary. I am directly writing a program, and at most I am writing an algorithm and then writing a program. And what are all these things? The significance of all these things will come into the picture once you start developing software for at least a mini project or for a real life project. Now, software design, it is the bridge between the user's needs and the actual code implementation. So, basically all these things are going to happen far before the coding starts. Who does coding? Developers do the coding, programmers do the coding. But then there are many roles prior to this particular role who do many things, and one of the activities which is very important is design. Now I want to explain you about the software design using one example. Now today let us consider a mobile banking app. Most of you must be having your mobile banking app in your mobile phones. Nowadays it's common that almost every bank is having a mobile app, and people normally transact using their mobiles for sake of ease and convenience. So today let me say the objective is to develop software for a mobile banking app for a bank. So the architecture that is proposed as part of the software design is it should be a client server architecture. See, I am not discussing about how we arrived at it. Okay. Basically, I want to create a feel of what is there inside the software design. What are all things that become significant when you develop the software. So, in case you are developing a mobile banking app, you need to decide the architecture. So, the architecture is client server architecture, which is a 3-tier architecture. So, the client will be the mobile app. It interacts with the application server, which is a middle tier, and which in turn interacts with the database server, where the huge database of your transactions or your accounts or the customers lies. So, here in the software design, one thing is architecture. So, we proposed that the architecture should be client server architecture. The next is what are the components of the app or the software. One is mobile client. It is installed on the user's phone. That is what you install from your App Store or Google Play. Then comes API gateway or server. It handles all the incoming requests from the clients. Okay, suppose you want to know the balance of your account. That is an input request. I mean, that is a request coming from the input. Of course, request means it is normally input when it is coming from the end user. Then authentication service. It verifies user credential and issues tokens. Transaction service. It processes fund transfers and bill payments. Core banking database. It stores customer account balances and transaction history. So, the components of the mobile banking app that needs to be built are mobile client, API gateway or server, authentication service, transaction service, and core banking database. Now, what modules are to be there in this particular mobile banking app? The modules are, again, one needs to understand that whatever are part of the design may be modified at a later stage in case there are new requirements. One is user interface module. It handles screen rendering and user interaction. Then comes security module. It manages encryption and session tokens. Then account module. It displays the balance and statement details. Transfer module. It manages the logic for moving funds between the accounts. So, these are the modules that are proposed as part of the software design. It is a design which uncovered that these modules are needed. To come to this particular step, you must have done a lot of work prior to that, which we will be discussing as part of the data design and architectural design. Then what interfaces should be there? Okay. For example, let me say we are speaking about a mobile banking app. The interface which we are offering for a mobile banking app users may not be the same for the people who will be using their browser, okay, which is web banking, and normally people say net banking. Okay. So one is REST API, the standardized way the mobile client communicates with API, gateway or server. REST, it stands for Representational State Transfer Application Programming Interface. It typically uses standard HTTP methods. Then internal interfaces, code level interfaces used by the transfer module to interact with the authentication service and database. Basically, internal interfaces are those which are not visualized by the user. Basically, user is interested in sending a request and looking at the output. Whatever internally happens, the control transfers from one module to another module, all those things are internal, but in the design, everything comes into the picture. Then comes customer data, name, address, contact information and other things. Account data, okay, the number of the account, whether it is a savings bank account or a recurring account, okay, the balance, the current balance, the type of the account which I already mentioned, but account number becomes unique, whatever it is. Transaction data. In the transaction data, we will include the date, when the transaction was done, at what time it was done, then the amount, the sender account, the receiver account, and the status, whether it was successful or not successful. So these are the different components that are part of the software design related to a mobile banking app. Now, how you really do a software design? Okay, so here this particular diagram shows you how the software design is done. Okay, so basically three things you see in the diagram. One is user requirements, the other is system design, and the final one is code. So as part of the user requirements, you get the information model, functional model, and some requirements. These three are input to the system design, and the output of system design, which takes information model, functional model, and requirements as input, are data design and procedural design. These become input to the coding module. And once the code is ready, you have to just test it and implement it. So let us see what is information model. It is designed to provide a shared, stable, and organized structure of information requirements for all stakeholders, from business users to software developers. The components of the information model are entities, attributes, relationships, rules, and constraints. So basically, what comes to your mind when you hear entities, attributes, relationships, rules, and constraints? ER diagram, entity relationship diagram. So basically, information model is designed to provide a stable, shared, and organized structure of information requirements for all the stakeholders, okay, for starting from the users to the developers. And basically, what is part of it? The part is ER diagram. Now let us see what is functional model. Basically, functional model focuses on what the system does, what the system has to do. So we are focusing on the system's output. It includes function, processes, and transformations that covers input into outputs. So what comes to your mind whenever we say functions, processes, transformations, and that transforms inputs to outputs? That is basically a data flow diagram. So the most common way to represent a functional model is through a data flow diagram. So in the case of information model, it is an entity relationship diagram. In the case of functional model, it is a data flow diagram. Then comes data design. So now let us see what is meant by data design. It is the part of software design process that focuses on defining, organizing, and structuring the data required by a software application. It translates the high-level business concepts from the information model and the functional requirements from the functional model into a precise implementable blueprint for a data storage and the management. So basically, the input to the data design is information model as well as functional model. In the case of information model and functional model, what we are getting? We are getting entity relationship diagram, we are getting data flow diagram. Basically, the information pertaining to ER diagram and pertaining to data flow diagram become input to the data design. So the goal of data design is to create a robust, efficient, and maintainable structure for data that ensures data integrity and accuracy. It means that the data is consistent and follows all the defined business rules, including the constraints. Efficiency, data can be stored, retrieved, and updated quickly and with minimal resource usage. Reduced redundancy, data is not unnecessarily duplicated, which saves space and prevents inconsistencies. And then scalability, the structure can handle growth in data volume and user load over the time. So basically, these are the goals of the data design. So if your data design is in order, all these goals are fulfilled. Now let us see the output of the data design. The output of data design is conceptual data model, that is entity relationship diagram, logical data model, the tables, fields, keys and data types. Then the physical data model, in this actual database schema, including specific DBMS data types, indices, stored procedures and storage parameters. So conceptual data model, logical data model, physical data model, these are the output of the data design. Now what is procedural design? Basically, whenever we are discussing about the procedural design, one very important thing is that if you look at the diagram, here you can see that we had information model, we had functional model, we had requirements, which are input to the system design. And the output is the data design as well as procedural design. And in the data design, you are getting the entity relationship diagram, data flow diagram, and over and above both of them, which even we got which as part of the input, the other aspects that are not part of the entity relationship diagram and data flow diagram. Apart from all these three, we also have what is called procedural design. So if you look at the procedural design, let us see what is procedural design. It focuses on transforming the structural elements of a software system, such as module and data, into detailed step-by-step instructions, that is procedures or algorithms for implementation. The output is pseudocode, flowcharts, decision tables or trees, the tools that are used to model complex conditional logic clearly and completely. These are the things which you already know. You have heard many number of times. Because function-oriented design, procedure-oriented design, these are very famous words which you were hearing. And when you started programming, you were using functions, procedures, all these things. So this is not much different from what you already know, but this is one of the outputs of the system design that directly goes as input to the coding module. So the output of the procedural design is pseudocode, flowcharts, decision tables or trees, tools used to model complex conditional logic clearly and completely. Now let us see some technical aspects of the design. As part of the design, you have data design, architectural design, modular design, and human computer interface design. Though we focus on data design and architectural design in today's lecture. So first of all, let us see what are different modeling techniques. One is elementary modeling techniques. Then we have behavioral modeling techniques. In behavioral modeling techniques, one is data flow diagrams, then comes data dictionary, then comes ER diagram, and then comes process specification. These are behavioral modeling techniques. In elementary modeling techniques, we have two models. One is environmental model, the other is behavioral model. So in the environmental model, let me say of an educational system, you have a national education system, then you have a university, then you have a college, you have a department. Okay, so the courses offered to students, they are part of the department. Then interfaces to external systems, that is between university and the college, and between college and department, and between the national education system and the university. These are different interfaces. Now let us see what is architectural design. The reason for introducing all these things is that when you are studying the architectural design, these particular concepts will be used. Then it will become easy for you to know what is meant by architectural design. IEEE defines architectural design as the process of defining a collection of hardware and software components and their interfaces to establish the framework for the development of a computer system. So this is the definition of architectural design as per IEEE, and IEEE is the supreme technical body which defines everything related to technology. So this is a standard definition that is agreed across the world. So let me just read out once again. IEEE defines architectural design as the process of defining a collection of hardware and software components and their interfaces to establish the framework for the development of a computer system. So again, if we have to understand exactly what is architectural design, the best thing is that what are the inputs to architectural design and what are the outputs of the architectural design. Once we understand these two things, then we will be better off understanding what is meant by architectural design. So the example application for architectural design is e-commerce platform. So the inputs to the architectural design are functional requirements, non-functional requirements, and constraints and technology decisions. These are the three major inputs. And in functional requirements, we work out on user management, product catalog, shopping cart, checkout and order processing, and the fulfillment. These are the different requirements of this particular application for which we are working out on architectural design. The non-functional requirements are scalability, performance, security, availability, maintainability, and extensibility. These are the non-functional requirements. Okay, because when you are fulfilling the non-functional requirements, many things come into the picture, like internet speed, the hardware which you are using, all those things. Now, the constraints and technology decisions are data volume. So it should be in a position to manage petabytes of historical transaction and log data. Then the existing systems, there should be a good integration with the existing systems of the new application that is going to be built. So it must integrate with an existing legacy warehousing management system which is already existing. Then budget and skills. Preference for cloud native solutions such as Amazon Web Server, Azure, and use of existing internal expertise in Java and Python. So these are the requirements of the system. All these things are requirements of the system, and ultimately whatever software was developed, it has to fulfill all these requirements. Now the outputs of the architectural design are, one is the chosen architectural style and the component definition, architectural views, deployment and process, interface and data storage specification, quality attribute strategies. So these are the 4 outputs of the architectural design for this particular application. Under each output, you will have many components. So one is like if you say choose an architectural style and component definition, the architecture preferred is microservices architecture, and what are all components of the microservices architecture were listed. Then comes architectural views, deployment and process. One is a logical view, the other is a deployment view, and the other is the process view. Interface and data storage specification, we have external interfaces, internal interfaces, and polyglot persistence, of which catalog service, inventory, and order service are part. Then finally, quality attribute strategies. The other, they are scalability strategy and security strategy. So these are the inputs and outputs of the architectural design. But how to take input and how to arrive at the output of the for the architectural design, we will be looking in the future. So thank you very much for all of you for attending today's lecture. In case you have any doubts, please feel free to email me. Thanks a lot.